here we have special right triangle 6-6. So we got a right isosceles triangle. So this side is congruent to this side, and this is a right angle, and this long side, everybody knows that's the hypotenuse. So, and if this is an isosceles triangle, those two sides are congruent, and by definition we also know that these two angles are also congruent. Everybody knows if we add up all three angles of the triangle, they must add up to 180. If this one is 90 and these two are congruent, so these two must be 45 degrees each. Alright, so now the one thing some of you might get confused is by labeling the sides. So if this is the right angle, the side that is opposite to the right angle, that's the hypotenuse. Hypotenuse right there. So this is 45, the one opposite to that 45. So this one right here, this is the side opposite to 45, and this is the side opposite to 45. Alright. So now that you know that, we already knew, but it's more like a review of that. So there's a ratio that you will have to remember, or at least have that written down in your notes. So this is the 45, 45, 90 triangle, or the right isosceles. And the one thing you're going to have to know is the ratios. So it's x, x, and then x square root of 2. So that means the lengths of the sides are within that ratio. So if this one is 45, the side that is to the 45, that is opposite to that 45, is going to be the length of x. The side of that 45, the side that is opposite to that 45-degree angle, we see it right there, so it's x. Opposite. Opposite from here to there. And the 90-degree opposite, everybody knows it's called hypotenuse, and the length will be x square root of 2. Alright, and then we're going to work on some more examples, and that's going to make more sense. Right now we're just learning how to label the sides in relation to the angles. Another special right triangle is the 30, 60, 90 degree triangle. So again, this is the 90-degree angle, and everybody knows that right here will be the hypotenuse. So this is going to be the 60-degree angle, and this is going to be the 30-degree angle. Big one, little one, and then 90 degrees. Just like what we did for the right isosceles, we're going to label them. So again, 30, the side that it's opposite to the 30, it's going to be this one. And this is going to be x. Let me put the ratios right here on the side. So 30, 60, 90. And the ratios are x, x square root of 3, and 2x. So the 30-degree, the side that is opposite to the 30-degree angle, that is the side with x length. The side opposite to the 60-degree, so this side right here, opposite to the 60-degree side, the 60-degree angle is going to have x square root of 3, and then the hypotenuse is going to be the longest one of all three, so the hypotenuse is opposite to the 90-degree angle, so it's right here, so 2x. So this is going to be really important to have on your notes, and being able to label all the three sides of the triangle in relationship to the angles, that's also really important. So we have a couple examples here over special rights. So here we need to find the length of this side right here. This is a 30, 60, 90 triangle. So before I even start doing anything, I need to write down the ratios. So for the 30, the ratio is x. For 60 is x square root of 3, and 90 is going to be 2x. Alright, so remember that the way we label the sides, 30, you look at the opposite side, that's D right there. 60, opposite to 60 is 6. So we're going to use this little table we have to solve our problem. So 30 and the side right here is D, and 60, our side here is 6. Now the 90 over here doesn't really matter at this time because it's not asking us to find the perimeter or anything like that. You will find some questions that will ask you to find the perimeter of all this, but don't worry about it right now. We're going to get there later. Alright, and you're like, what do I do with this? This is going to be a find x type problem since we're trying to find D. We have that x square root of 3 equals 6. So, because this is what we have. We're trying to find x right here. If we were to do something, oh, x is D, but we don't have anything that will help us out right here. So, but we can totally find x because we know that x square root of 3 equals 6. That we know by looking at the triangle. How are we going to solve this? So we got x square root of 3 equals 6. So for us to isolate x is multiplying the square root of 3, so we need to divide both sides by square root of 3. These two go bye-bye or simplify, equals 1. And then you get that x equals 6 square root of 3. But remember, we just learned that we cannot have square root of 3 in the denominator, so we need to do our little trick, which we multiply numerator and denominator by the square root of 3. So now we're going to multiply here on top. We have 6 square root of 3. But then when we multiply the radicals here, we're going to do 3 times 3, and we get square root of 9. 3 times 3 is 9, and the square root remains because we're multiplying what's inside of the radical. So you're like, oh yeah, I can take the square root of 9, and I get 3. And still I can't do anything with the numerator right now until I get to this fraction. 6 over 3 I can simplify, and I get 2 on top. So 2 square root of 3. Oh yeah, so equals D. This is my final answer. Now you're wondering why we spend so much time trying to simplify radicals. This is why right here. The other one, we also have a 30, 60, 90 triangle. Now this time, we got the length of the 30-degree side, and we're looking for C. But remember what I said, before we even start solving this, we need to write down the ratios. So 30, 60, 90, and we know the ratios are x square root of 3, and 2x. Alright, so now here we have that 30, this side is 3 square root of 3, and the 60, we have the opposite side is C, and 90, we don't have anything on the 90, so we are going to leave that one alone. Alright, so now we have equals here. We got x equals that, but then we're looking for C. So we're going to have to do a two-step thingy right here. So we know x equals 3 square root of 3. And we also know that C equals x square root of 3. So x is simply 3 square root of 3. I can get this guy right here, and plug that in to x, because x equals this guy. So I can tell that c equals 3 square root of 3, this guy right here, times my square root of 3 right there. So one more time, this is x from here, that I knew that x was this guy right here, 3 square root of 3. I replaced it right here. That's where I have the 3 square root of 3 right there. And this square root of 3 was given from my ratio. Boom. Okay, so now we just need to make it look better. So c equals, I'm going to multiply what's inside of the radical. This dude right here stays alone. Leave that dude alone. So 3, because it's outside of the square root. So 3 times 3, we're going to take the square root of 9, because the radical remains. So 3 times 3, 9 right there. Alright. And everybody knows the square root of 9 is 3. Oh yay, it's looking better. So 3 times 3, 9. Find c. C is my answer right there. C equals 9. Here we go, 2 more examples. Now for example 3, we need to find a. A is right here. And you're like, well, but I don't know what the degrees are for this triangle right here. But hey, these two angles are congruent. If this one is 90 and all together you need 180, you know for a fact that these two have to be 45 degrees. Alright, so with that being said, before we start solving, you need to write down the ratios for the 45, 45, 90, or the right isosceles triangle. So x, x, and x square root of 2. Alright, so we have this side right here of opposite to 45 is a. We know that they're the same, so here we go. And then the 90 degrees, the hypotenuse, is 7 square root of 2. Now, we know these two are equal. X square root of 2 equals 7 square root of 2. We need to put x together because we're looking for x, which is the same as a. We need to divide both sides by square root of 2. We get rid of this because square root of 2 divided by square root of 2 is 1, or they go bye-bye, or they cancel out. If they cancel out over here, why wouldn't they cancel out over here? Boom. That will leave me x equals 7. But the question is not asking for x, the question is asking for a, and we know a equals 7 because I'm looking at my ratios right there. Here's the shortcut. You're like, why are you doing all of this? If I can just totally tell that square root of 2 square root of 2, x is the number in front, so x is 7 right here. Boom, I don't have to do all this nonsense. You're right. If you don't see that, you're welcome to do all this math. If you can see that, more power to you. That will save you a good 5 minutes right there. So on example 4, on the other hand, you have the leg and you're looking for the hypotenuse. And again, you have to write down the ratios before you start solving them. And the ratios are x, x, x square root of 2. And then here we're looking for the hypotenuse, so we're looking for v. And they gave us x, x square root of 3. So if we're looking for v, v is the hypotenuse. And we know that x is square root of 3. So x is square root of 3. And we're looking for v, the hypotenuse right there. Remember, always the opposite side to the 90-degree angle. That's the hypotenuse. That's v that you're looking for. So the only thing that you need to do here, super easy shortcut, this guy right here, x is square root of 3. So you just plug that in. Boom. So x, or v, equals x square root of 2. And we know this guy is square root of 3. So v equals square root of 3 times square root of 2. I'm substituting square root of 3 for x right here. Now, this doesn't look good. You make it look pretty. So multiply what's inside of the radical. 2 times 3, 6. And you know 6 is not a perfect square, so you leave that thing alone. Boom, that's your final answer.